The Intergovernmental Panel on Climate Change recently reported findings that global agricultural activities are responsible for approximately 25% of greenhouse gas emissions from human-related activities, with the primary gases of concern being nitrous oxide and methane. Dairy systems produce both of these gases, but scientists believe that management opportunities exist for mitigating these emissions. As part of their sustainability efforts, the U.S. dairy industry is committed to reducing their greenhouse gas emissions by 25% by the year 2020. In order to advise the industry in meeting this goal, scientists associated with the Sustainable Dairy Project, funded by the USDA National Institute for Food and Agriculture, are researching alternative management practices for use in the Great Lakes region. One management technique that's being studied is the addition of tannins to dairy cow diets. In a collaborative effort between the University of Wisconsin-Madison and the USDA ARS Dairy Forage Research Station, scientists are following the effects of the tannins from the animal digestion process to the collection and storage of the manure, all the way onto the field application and crop use of manure nitrogen. Initial studies indicate that increasing the amounts of tannin in the animal feed enhances the uptake of protein from the feed and reduces nitrogen losses to the environment. Tannins are polyphenolic compounds that are found in many leguminous plants. When consumed by the cows, the tannins act as protein binding agents, allowing for uptake later in the digestive process and reducing the amount of urea that is produced during digestion. This in turn results in less nitrogen being excreted as urea in urine and lost as ammonia and nitrous oxide during manure collection, storage, and field application. Managing diets to encourage more feed protein ending up in the milk rather than the manure is one way to reduce losses of ammonia and nitrous oxide from dairy farms. With nitrous oxide having a global warming potential that's nearly 300 times that of carbon dioxide, reducing losses will be an important element in meeting the industry goal of greenhouse gas emission reduction. The systematic effect of adding tannins to feed on methane emissions remains unclear. Tannins are typically bitter, so convincing the cows to eat them can be tricky, and if fed in too high of amounts, they may decrease feed intake and milk production. Because of the potential for greenhouse gas emission mitigation, scientists are studying these and other trade-offs to production system management. In order to make recommendations for increased sustainability, we hope to gain more information on the interactive effects of the level of tannins in the livestock feed on milk production, manure quality, soil fertility, and greenhouse gas emissions.